Now for synthetic division. So I had mentioned in the last video that you guys are really going to like synthetic division because it's much, much faster than performing long division. Now, there's a couple things that you have to keep in mind. Notice that it says synthetic division may be used to divide polynomials if the divisor is of the form x minus c. That means that the coefficient on x can only be 1. If you had something, for instance, like 3x minus 5, we can't use long division. If you had, let's do 10x squared minus 3, right? Can't do long division. So x squared doesn't work, 10 times x doesn't work. So none of these could be used, or could we use synthetic division? So how do we do it? So we arrange the polynomial in descending powers, which we had done before. Then notice it says we have to put a 0 coefficient for any missing terms. We did that before. Write c for the divisor, which is of the form x minus c, to the right, and write the coefficients of the dividend. So just the coefficients. All right, and then the rest is we're going to bring down the first leading coefficient, multiply the divisor by that, put them in the next columns, and then add down the columns. But let me go ahead and perform it. I think it's much easier for you to understand if I'm explaining how it's done as I'm actually doing it. So the most important thing is, right, notice it says x minus c is the form that we need. So my divisor here is x plus 3. You might want to write that as x minus a negative 3. That's the form that we need. So that means that I need to put a negative 3 on the outside. Okay. Then I put the coefficients of my dividend. So 1, 10, and 21. You bring the first coefficient down and write on the outside. You multiply my divisor number, the negative 3, by this 1, and you're going to put it there. So negative 3 times 1 is negative 3. Then you add down the column. 10 minus 3 is 7. Then you multiply this, and the result is going to go there. So negative 3 times 7 is negative 21. Add down the column, you get 0. All right. Now, what's the result? Well, these are coefficients. So this right here is our remainder. Then this, the next term, is a constant. The following terms are coefficients for powers of x. And so if you think about it, really what this means is it's, this term would be x to the first, this is x to the 0, and then our remainder. If there were more terms to the left, then they would be the coefficients for the x squared and x cubed and so on. So what does our final answer actually look like? Well, we have 1 times x to the first, or x, and 7 times x to the 0, or 7. And you'll notice that's the exact factor that we got the last time we did this problem, but using long division. I'm going to bet this is much more up your alley. All right, let's take a look at yet another example. Here I have x cubed minus 7x minus 6 being divided by x minus 2. This is already in the correct form of x minus c, so c is 2 in this case. I put that on the outside of my synthetic division. Then I need my coefficients on my terms. Notice I do not have an x squared term, so my coefficient's going to be 0. So I have 1 on x cubed, 0 on x squared, minus 7 on x, and then minus 6. Bring the first term down. 2 minus 1 is 2. Add down the column. We get 2. 2 times 2 is 4. Put that here. Add down the column. Negative 7 plus 4. is -3. 2 times -3 is -6. Add down the column, we get -12. So it appears this time we end up with a remainder. Okay, so remember that the last term is the remainder. This is a constant. And the rest are coefficients on, this would be x to the first. This is a coefficient for x squared. So my factor is 1x squared plus 2x minus 3, and then minus 12 over x minus 2. This is another example that we've already done, so we know the answer, but let's go ahead and use long division. Remember that we need to put the c on the outside, which is 7 in this case, right? Because it's of the form x minus c already. Then I need to do descending order. So x to the 4th is my only power of x here, so I have a 1 in front of that. Then I have 0x cubed, 0x squared, 0x, and then finally my constant 2,401. Bring the 1 down. 7 times 1 is 7. Add down the column. 7 times 7 is 49. Add down the column. 7 times 49, I believe, was 343. Add down that column. And 7 times 343 turned out to be 2,401. If we add down that column, we get 0. So we have a 0 remainder. Then this is our constant. And then we have this for x to the first, x to the second, and x to the third. So our factor is x cubed plus 7x squared plus 49x plus 343. And that's it, right? There's no remainder, so that is our factor. Next is called the remainder theorem. So this is interesting in that if you have a function f of x, which is a polynomial, and you're trying to divide by an x minus c term, then the remainder is going to be the function evaluated at c. So let's take a look here. We have f of x equals 5x cubed plus 6x plus 8, and they're telling us that c equals -2. So evaluate the function at -2. So we're going to do f of -2, which is 5 times -2 cubed plus 6 times -2 plus 8. -2 cubed is 8, or -8. And then we have 6 times -2, that's -12 plus 8. 5 times -8 is -40. -12 plus 8, that's going to end up being -44. So that's going to be our remainder. Now let's test this out. Let's actually perform polynomial division and see if we end up with this as our remainder. I'm assuming you're going to want to do synthetic division, so let's do that. And they told us what c was, so that's nice, right? So c is -2. My polynomial's here, so I need to put 5 for x cubed. Notice there is no x squared. Then I have 6 for the x, and I have 8 for my constant. Remember to bring the 5 down, multiply those two, and put the result here. Add down the column. Perform multiplication again, and add down the column. And then finally multiply these two. So that's going to be -52. And that's exactly what we had before, right? We had -52 plus 8, which is -44. Okay, that's part B of the problem. Part C says, comment on your answers. Well, they are the same.